Welcome to my channel Chemica Chemistry Classes. Today we are going to discuss isomerism. Isomerism is first we try to understand what is isomerism. Isomerism in organic chemistry, two or more compounds that have a same molecular formula but different structure formula. Such compounds are known as isomers, and this phenomena is known as isomerism. This phenomena is known as isomerism, right? So, since these compounds have different structure formula, they differ in both physical and chemical properties, right? So, in isomerism, we have same molecular formula, but their arrangements are different, right? So, types of isomerism. There are two types of isomerism, that is structure isomerism and stereoisomerism. Structure and stereoisomerism, right? Structure isomerism is this isomerism is due to different arrangements of atoms within the molecule. There are different arrangements of atoms within the molecule. But in stereoisomers, from their name, this is due to the different spatial arrangements of atoms or group around a particular atom in the molecule. There is a different arrangements. I will explain you in detail. First, we are considering structure isomerism. Structure isomerism is further divided into 5 types. These are chain isomerism, position isomerism, functional isomerism, metamerism, tautomerism. They are the 5 types of structure isomerism. We will discuss one by one in detail. In structure isomerism, right? In structure isomerism, we are discussing structure isomerism. Structure isomerism, first one is a chain isomerism. First, their type is chain isomerism. In this isomerism, they differ in the order in which carbon atoms are linked in a molecule. When atoms are linked in a molecules or in a chain, they differ in which order carbon atom is attached. In chain isomerism, that's all depends upon the order in which carbon atoms attach. Second one is the position isomerism. From their name, they highlight the position. Something is related to position, right? So they differ in the placement of functional group on the carbon chain or placement of multiple bonds. There is a multiple bonds. In position isomerism, we are considering functional groups position and bonds position, single bond, double bond and triple bond. Main focus on the functional group and the bonds, right? Third isomerism is the functional isomerism. From their name, they differ in the functional group. Fourth one is metamerism. They differ in group attached to functional group. They differ in their group, then they are attached to some functional group. Next is tautomerism. Migration of proton from carbon atom to adjacent atom. The two atom forms are in dynamic equilibrium with each other, and one of the example is ethyl acetoacetate. I will explain you with this structure. Ethyl acetoacetate. The structure is this. They have two forms, enol forms and keto forms, right? I said there is equilibrium between both forms, right? So, next form is this one, not this. No, not this is OH, and double bond is here, CH, and this OC, H5. So this form is their keto form and this is their enol form, right? So this is the tautomerism. So this compound shows the properties of both keto and enol form. Next type is stereoisomerism. In stereoisomerism, there is some categories. Like this is in this isomer, there is a spatial arrangements of atoms or group around a particular atom in the molecule. So there are some terms or groups that are mainly used in stereoisomerism. I will explain you that term. First of all, stereoisomerism is further divided into two types. Here you can see this, that is geometrical and optical isomerism, right? So first of all, we discuss the geometrical isomerism. In geometrical isomerism, in this there is a restricted motion within the molecule. There is some restriction in the molecule. For example, I will tell you, the restriction is on the basis of their structure, because we are studying geometrical, we are studying geometries, right? So this is like this. So I am drawing the structure of cis 2 butene, right? This is cis 2 butene, and then I am drawing the structure of trans. There is difference in cis and trans, that is based on their structure. You can identify which one is cis and which one is trans, right? So this is cis form and this is trans form, right? So in cis form, similar groups are on the same side, and whereas in trans form they are on the opposite side. This is about the geometrical isomerism, right? Next is the optical isomerism. They differ in the capacity to rotate the plane polarized light. They have to rotate the plane polarized in the opposite direction. So some terms which are used in this isomer is optical active. First one is optical active molecule. These are some important terms which are used to understand this isomerism. This isomerism, optical isomerism, is purely based on the rotation of plane polarized light. Their terms levorotatory, dextrorotatory, all depends upon the light, right? So in optical active molecule is a molecule that cannot be superimposed on the mirror image, and it is also called the chiral molecule. Superimposed means when a molecule and its mirror image can be placed on top of each other in such a way that every part of one coincides perfectly with the other, making them identical in their structure. Next is the chiral carbon. As you know, chiral carbon means carbon is attached to different groups, right? So that is a chiral one. Enantiomers means the optical isomer which are mirror image of each other, that are enantiomer. Next term is the dextrorotatory and levorotatory. Dextrorotatory and levorotatory. Dextrorotatory we can also represent by positive sign, and levo we can represent by negative sign. In dextrorotatory, an isomer which rotate the plane polarized light to the right direction, or we can say in a clockwise direction. In levorotatory, plane polarized light are rotate on left hand side, or we can say on anti-clockwise. Right, so this is about dextro and levo. Dextrorotatory means an isomer which rotates the plane of polarized light to the right direction, and levorotatory an isomer which can rotate the plane polarized light towards the left. Racemic mixture. Racemic mixture means an equimolar mixture of two isomers. Since the optically rotatory powers of two isomers are equal in magnitude but opposite in sign, so the racemic mixture does not rotate the plane of polarized light. So the two isomers in a racemic mixture cannot be separated by laboratory method, as two isomers resemble each other closely in all properties except optical. Next is a diastereomers. And optical isomers that are not mirror image. Diastereomers are observed if the molecule contains more than one chiral carbon atom. The two isomers have the same configuration respect to one chiral atom, and will have different configuration with respect to the rest of the molecule. I will show you with one example, that is, as you can see, This is positive tartaric acid. You can say it positive, and when the position of OH, or you can say H hydrogen is changed, then there is negative sign, right? Positive tartaric acid, negative acids are enantiomer, whereas the positive tartaric acid and negative are mesotartaric acid are diastereomers. They are diastereomers. How can you say? If you draw a plane of symmetry with this as this, when OH attached here and OH attached here and H and H, then last one is a resolution. Resolution means the separation of a racemic mixture into its two optically active component is known as resolution. That's it. So this is all about the isomerism. There are two types, that is structure and stereoisomer, and structure isomers is further divided into categories, that is chain, position, functional, metamerism, tautomerism, and stereoisomers is divided into two, that is geometrical isomerism and optical isomerism. Thank you.